Hey guys, it's your boy here, Sheen Kalian. You know, lately I've been thinking. At the beginning of my channel intro, I said I was going to do something, smart, intellectual. Well, all I've been doing is dumb stuff. So I decided, even though this is probably not what you're wanting, you're probably wanting me to do more stupid stuff. Well, this is my channel. Get used to it. I'm going to do a few things my way. Today, we're going to be talking about FMA. And if you don't know what FMA is, it's an acronym. It stands for Force times Mass equals Acceleration. It's one of my most favorite of all of physics equations. It's one of my favorites. I mean, it doesn't compare to E equals mc squared. That's cool too. But I'm going to teach you how FMA actually works and how it actually affects our entire world, possibly our entire universe, because the laws of physics is our universe. Now, I could go on and explain how the laws of physics exists but doesn't exist in our own reality. I will be talking about that pretty damn soon, actually. So, what I have here is just a little rock. I'm going to throw this rock up in the air. That is our force. When I toss this rock up into the air, it will be affected by our law of gravity. The law of gravity was created. Well, it wasn't even created. The thought of gravity was developed by Isaac Newton. The legend says an apple hit him in the head and said, oh, that must be gravity, even though he completely made up that word by himself. Gravity is one of our most important laws of physics. Matter of fact, it's the most important law of all physics. It defines how we live. Without it, our world would not be stable. Our sun could not exist. Our universe could not exist. If we had no gravity right now, most people would say, oh, we would just float off into space. Not essentially true. All matter in the universe would just float away. Matter could not exist if there was no gravity holding everything together. So, for example, I got the pebble again, a little rock. Now, I weighed this rock. This is about less than a gram. Now, I'm going to throw it up about 15 feet in the air. And yes, I can do that. I'm not. Now, that rock just went up. To create a 15, to go up 15 feet, that means I would have to apply 15 newtons. If I am correct. I'm pretty sure. Because I'm going against the laws of gravity. It wouldn't take much for me to throw it 15 feet. But while it was going up so fast, it was being pulled back down by gravity. Now you're probably wondering, what does that got to do with anything? Well, now that we have our mass, which is only a gram, and our force, which is only around 15 newtons at the most, when it's coming back down, that is when we get our acceleration. And that is when the acceleration doubles the mass. No, even triples. So when we throw this little pebble up in the air, it becomes very dense as it's being pulled back down. Now you guys can see the car coming. Anyways, back to it. When we throw it up, it's going to be pulled back down, and which causes it to accelerate. So instead of feeling like 1 gram, it's doubling each time, every little millimeter it falls, and it just keeps on coming. Its mass may be the same, but its acceleration is what will make it feel like you're getting hit by a brick instead of a little pebble. To put that in an example, that's kind of how hail works. When it falls out of the sky, even a little tiny little piece of ice, but it's coming down so fast that it feels like you've just been hit by a bullet. And it might even go through your skull. I don't know. It just depends on how fast the acceleration is. And it's since gravity is pulling it down, that's causing the newtons, the force, to keep pulling it down. Keeps going up, the force. Sorry, that might have sounded a bit confusing. The newtons, which is the force, pulls it down. Hey, bro. What are you doing? Anyway, it is extremely, it becomes, from this little pebble, goes to a brick. From that brick, can go from something even larger. It just depends on how high it goes, how fast it goes down. I mean, it doesn't even matter if the speed. It's just the force and the mass. That creates the acceleration, which causes even more damage. That's a lot of damage. It's not only that you might see in the world. There are many examples. Hail. I'm going to go back to hail. Hail, when it falls down, its force is being doubled every time it's being pulled down, because gravity is forcing it down further and further. Because out here, the gravity is not as strong, but the deeper you pull it down into the atmosphere, the stronger the force will get, which will cause the acceleration to increase and the force as well. So when that little pebble comes hurling down, hits you right in the top of your noggin, hits you right on your noggin, well, it feels like a ton of bricks. And it's the same with anything. Now, there are different situations that you could put FMA. Remember, this has to do with the laws of physics. One of the most important, actually. So I think I'm going to end it now. I hope I've taught you a little bit about FMA today. I'm going to be going over some other things pretty darn soon. I'm going to start talking to you about GMOs, genetically modified organisms. And I'm going to decipher if they are actually good or if they're bad for humanity. Okay, I'll see you till then. See you guys.